Hello everyone. Here I'll be discussing as our JEST exam is approaching. It's next Sunday. So I'll be solving the PYQs of electromagnetism. Right. So I'll try to solve all the PYQs like up to 2016 to 2021. Okay, I have these only, so I will try to solve them. Okay. So electromagnetism, JEST PYQs, and in this video I'll be doing 2016 to 2021. And 23 I'll be doing in the next video. Okay, so the first question: the relativistic maximum relativistic kinetic energy of beta particles from a radioactive nucleus radioactive radioactive nucleus is equal to the raised mass the raised mass energy of the particle. Okay, a magnetic field is applied. A magnetic field is applied. Magnetic field is applied perpendicular to the magnetic field is applied perpendicular to the beam of beta particles. Perpendicular to the beam of beta particles. Okay, which bends it, which bends it um, to a circle of radius to a circle. It bends it to a circle of radius r. Is r. Okay. The field is given by the field is given by okay. Field is given by option A 3 m naught c by er. Option B root 2 m naught c by er. Option C root 3 m naught c by er. Option D root 3 m naught c by 2er. This question came in JS 2016. The maximum relativistic kinetic energy of beta particles from a radioactive nucleus is equal to the rest mass energy of the particle. So maximum kinetic energy is equal to rest mass energy of beta particles of the particle. Sorry, of beta is equal to rest mass energy of the particle. Yeah, that means beta. Yeah, a magnetic field is applied perpendicular to the. These are beta particles. Magnetic field is applied perpendicular to the field. To the beta particles, which bends it into a circular motion. So the beta particles are moving in a circular motion of radius r. The field is given by. Okay, the field is given by. So how do you approach it? Just try this question first. Maximum relativistic kinetic energy of beta particles from a radioactive nucleus is equal to the rest mass energy of the particle. Magnetic field is applied perpendicular to the beam of beta particles, which bends it into a circle of radius r. The field is given by. You have 2 minutes time. try. What happened inside? जाओ जीरो नाना में जाओ. Okay, so time is over. I hope you could solve it. Hmm. So see, maximum relativistic kinetic energy of beta particles from radioactive nucleus is equal to rest mass energy. So kinetic energy max is equal to what? Is equal to we know total energy is equal to kinetic energy plus rest mass energy. Okay, E is equal to mc square. Mc square is equal to kinetic energy plus rest mass energy is m naught c square because m naught is the rest mass. Okay, of a particle. So your kinetic energy becomes what? If you see mc square minus m naught c square is equal to kinetic energy, right? So kinetic energy max is equal to mc square minus m naught c square. Okay, which is in fact equal to how much? Relativistic kinetic energy beta particles is equal to rest mass energy. So which is in fact equal to rest mass energy m naught c square, isn't it? So m naught c square is equal to mc square minus m naught c square. Okay, so 2 m naught c square is equal to mc square. Okay, so c square cancelled out. So m is equal to 2 m naught. Okay, now what is the formula for m? What is the formula for m? M we know m formula is m naught by root over of 1 minus b square by c square is equal to 2 m naught, right? So m naught n naught will be cancelled out. So 1 divided by root over of 1 minus b square by c square is equal to 2. Okay, so take the square of both sides. 1 minus b square by c square is equal to 4. So 1 by 4 is equal to, this goes to that side, 1 minus b square minus c square. So v square by c square is equal to 1 minus 1 by 4. So v square by c square is equal to 3 by 4. So v square is equal to 3c square by 4. So v is equal to root 3 c by 2. Okay, so this is the velocity. So what is the question now? The question is, the field is given by, okay, the magnetic field is bending the beta particles into a circle. Okay, circle of radius r. We know what is the formula for it. We know radius formula when in this kind of situation is mb by qb. Okay, right, mb by qb. Like, how did this came? mv square by r is equal to qvv. From there it came. Okay, vv cancelled out. R goes to that side, so r is equal to mv by qv. So here r is given as capital R. So capital R is mv by qv. What is q? Q is the charge of the particle. Your beta particle is your what? Actually electron. So so mv by eb. Now v we have root 3 mv by m by eb into v. V is a root 3 c by 2, right? So that will be an answer. So root 3 mc divided by 2eb. Okay, 2eb is equal to r. But is r asked, or which one is asked in this question? Field is given by. So we have to find b, right? So take b to this side. Root 3 mc divided by 2er. That is the answer. So if you see, Did I do any mistake? Okay, okay, I got it. See this M, as this is moving, this is not your rest mass. This is your mass. Okay, M. So this M is actually what? 2m naught, na? Because m naught is a rest mass. So we have to put okay, yeah, yeah, yeah. Otherwise, yeah, see, if you see in the options, m naught is there, okay, in all the options. But we calculated it in terms of m only. Okay, we'll just put m naught here. M is equal to 2m naught. Here we have got in one of the steps m is equal to 2m naught. I will just put that here. So is equal to root 3 into 2m naught c divided by 2e. 2 to cancel out. So 3 m naught c divided by e. Okay. So this is a b. Is it alright? Yeah. Okay. And I hope you are clear about it. Okay. Next question I will write. Question number 2. Question number 2 I will write. The strength of magnetic field. The strength of magnetic field. The strength of magnetic field at the center of a regular hexagon regular hexagon with sides of length a, carrying a current carrying a current carrying a steady current I is, okay. Option A, mu naught I by root 3 pi a. Option B, root 6 mu naught I by pi a. Option C, 3 mu naught I by pi a. Option D, root 3 mu naught by pi a. So try this question. Okay. You have, wait. You have 3 minutes for this question. Okay. Please try this question. You have 3 minutes. Yeah. Please try. Sorry, I got a bit late. Okay, could you solve it? I hope you could solve it. Okay, see, the strength of magnetic field at the center of a regular hexagon with sides of length A carrying a steady current I is. So here, uh, the thing is, you have to first draw a hexagon, right? And after that, we will see how I can proceed. So, let's draw a hexagon first. Sorry for the drawing. This is the hexagon, right? So the current is moving like this. Okay, current is like this. I, 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 right? So this is the center, right? And the distance from the center is A. Distance from the center is A. That means this is A, this is A. So for a regular hexagon, what are the angle of all the angles is 120 degree, right? So if I draw A, so this will be your 60 degree, this will be your 60 degree, and this will also become 60 degree. So this is, if you see, an equilateral triangle with all the sides are A and all the angles are 60 degree, right? And current I is moving here. So if you see, if this is a curve, like this is 60 degree, right? Yeah. So if this is 60 degree, if I divide it like this in the middle, that will be your 30. That will be your 30. Okay. We know how to get a magnetic field. This is like this. This is your 30. This is your 30. And if this is A, what will be this one? This whole thing is A. So this is your A by 2. This is A by 2. This one will be what? A square minus A square by 4 whole root over. Okay. This is your 3A square by 4 whole root over root 3A by 2. Right? So this distance is actually root 3A by 2. Is it alright? Root 3A by 2. This is what we want. So for magnetic, this is current. So magnetic field here will be what? B is equal to B1. Suppose mu naught I by 4 pi r distance sine theta 1 plus sine theta 2. Correct? Okay. So mu naught I by 4 pi. What is the distance? Root 3a by 2. Root 3a by 2 sine 30 plus, both the angles are 30, right? Sine 30 plus sine 30. Okay. So this 2 to cancel out. Mu naught I by 2 root 3 pi a. Sine 30 is 1 by 2. 1 by 2 plus 1 by 2 is 1, right? So this is the answer. Mu naught I by, no, this is not the answer. Sorry, this is for only one triangle. There are how many triangles? One, two, three, four, five, six. Six triangles. So for six triangles, the whole it will be just multiply with six. I total is equal to 6 mu naught I by 2 root 3 pi a. Okay. So if I cancel 6 with 2, there will be root 3. So root 3 pi mu naught I by pi a. Okay. Yeah, that will be the answer. Okay, that was the second question. I'm really sorry for the background noise. I can't do anything about it. There's something going on near my locality. Okay, number three. Okay, suppose YZ plane forms this boundary, between two linear two linear dielectric media, 1 and 2, with dielectric constant with dielectric constant dielectric constant epsilon I is equal to 3, epsilon 1 is equal to 3, epsilon 2 is equal to 4 respectively. respectively. If the electric field in the region, if the electric field in the region, if the electric field in the region 1 at the interface, is given by E1 is equal to 4x E1 is equal to 4x cap plus 3y cap plus 5z cap. Then the electric field, then the electric field E2 at the interface, in region 2 is 4x cap plus 3y cap plus 5z cap. Option B 4x cap plus 0.75y cap minus 1.25z cap. Option C minus 3x cap plus 3y cap plus 5z cap. Option D 3x cap plus 3y cap plus 5z cap. Okay, this is the question. Suppose yz plane forms the boundary between two linear dilated media 1 and 2 with dilated constant epsilon 1 is equal to 3, epsilon 2 is equal to 4 respectively. The electric field in the region I at the interface is given E1 is equal to 4x cap plus 3y 5z cap. Then the electric field E2 at the interface is. Let's try this question, you have 2 minutes. You have 3 minutes, please try. Okay, could you solve it? Suppose YZ plane forms this boundary between two linear dielectric media, uh, 1 and 2 with Rayleigh constant epsilon 1 is equal to 3, epsilon 2 is equal to 4 respectively. The electric field in the region 1 at the interface given by E1 is equal to this. The electric field E2 on the interface in the region R2 uh, is will be. That is the question. So how do you solve it? See, this type of problems are boundary value problems, right? And there will be interface and there will be these two media and their dietary constant will be given. So epsilon I is equal to how much it is given 3 epsilon double I is equal to 4. So see in this kind of things your E parallel is equal to E in parallel. The parallel components are same. Okay. So YZ plane that means their YZ both of their YZ components will be same, right? So the YZ component of E1 is equal to 3 y cap plus 5 z cap. So for E2, yes, was 3 y cap plus 5 z cap. So that will be same. What we need is your x cap. Okay, so x cap we need. So for x cap, I have tried the formula. This is the formula will be E double I. This is perpendicular component, right? Because y z plane x will be a perpendicular component is equal to epsilon I by epsilon double I. Just remember this formula E1. Okay, this is the formula. So E double I perpendicular will be epsilon 1 is 3 by 4 into what is the perpendicular component of E1? That is a 4x cap. So just write 4x cap. So that will be a 3x cap. So just put the 3x cap here. Okay, and that will be E1. So E1 will be 3x cap plus 3y cap plus 5y cap. See how easy it is. Just have to remember this formula. Remember it this way, like E2 by E1 is equal to epsilon 1 by epsilon 2. Just remember this way, like inversely proportional. Okay, you can otherwise remember this one. E is equal to 1 by 4 pi epsilon naught. So epsilon naught is in the denominator. You can remember that way also. Okay, yeah. Okay, next question. So, question number 3. Question number 4. Question number 4 is how much force does light from a 1.8 watt laser exert when it's totally absorbed it's totally absorbed by an object by an object. How much force does light from a 1.8 watt laser exert when it's totally absorbed by an object? Option A 6 into 10 to the minus 9 newton. Option B 0 0.6 into 10 to the minus 9 newton. Option C 0 0.6 into 10 to the minus 8 newton. And option D 4.8 into 10 to the minus 8 newton. Okay, let's try this question. I'll just decrease the time for this one. You have 1.5 minutes for this question. How much force does light from a 1.8 watt laser exert when it's totally absorbed by an object? Try this question. Okay, could you solve it? How much force does light from a 1 watt? This is a direct kind of question. Right? 1 watt is that means power is given 1.8 watt. Okay, exhaust when it's totally absorbed by light. So this is what is how much force? Okay, so first of all we know the formula is radiation pressure. Okay, radiation pressure is equal to F by A is equal to I by C. Okay, intensity by speed of light. Hmm. Okay, so intensity is what power by area. Intensity is the power by area into C. C is C. Okay. So if you see force is equal to force by A is equal to P by AC. So A cancelled. So force is equal to P by C. Okay. Force is equal to P by C. So power is how much? 1.8 watt. So 1.8 divided by C, that is 3 into 10 to the power 8 meter per second. That is 0.6 into 10 to the power minus 8. What is the unit in Newton? I can write it also as 6 into 10 to the power minus 9 Newton. Okay. So it's just about formula. Just need to remember these formulas and we're able to solve it. 6 and 10 to the minus 9. Option A is the answer. Okay. Okay. Next question. Question number 5. A circular loop. A circular loop of radius r a uniform carries a uniform line charge density lambda. Okay. The electric field calculated at a distance z directly above the center of the loop directly above the center of the loop is maximum if z is equal to dash. Option A r by root 3, option B r by root 2, option C r by 2, option D 2r. So the question is circular loop of radius r carries a uniform line charge density lambda. The electric field calculated at a distance z directly above the center of the loop is maximum if z is equal to. Okay, you have 2 minutes for this. 1.5 minutes take. Yeah, you should take 1.5 minutes only for this question. Already 20 seconds long. Circular loop radius r carries a uniform line charge density lambda. The electric field calculated at distance z directly above the center of the loop is maximum if z is equal to dash. Okay. Circular loop of radius r is r carries a uniform line charge density lambda. The electric field calculated at the distance z. Okay, what is the formula for it? Electric field calculated at distance z above the center of the loop. The formula for it is what? Electric field is equal to 1 by 4 pi epsilon naught. Okay, lambda into 2 pi r z divided by r square plus z square to the power 3 by 2. Okay, so what is the question? The electric field calculated distance is maximum if z is equal. That means we have to do what? D by z dz is equal to 0 because electric field is maximum for z value. That means we have to take with respect to z. So d by dz of 1 by 4 pi epsilon naught lambda into 2 pi r into z r square plus z square whole to the power 3 by 2 is equal to 0. 1 by 4 pi epsilon naught and these are constant, they will go to that side, become 0. So d by dz of z by r square plus z square to the power 3 by 2 is equal to 0. Okay. So if I take the derivative, so r square plus z square to the power 3 by 2 square 3, and now r square plus z square to the power 3 by 2 dz by dz is 1 minus z, and derivative of this is derivative of v by u. So this one derivative is into 3 by 2 r square plus z square to the power 3 by 2 minus 1, that is 1 by 2 into the derivative of the inner part, that is 2z is equal to 0. Okay, so if you see 2 2 are cancelled. So if you see, if I will take this and to the right side becomes 0. So r square plus z square to the power 3 by 2 minus if you see z into z is z square and this is 3 z square r square plus z square to the power half is equal to 0. Okay, so now I will take this to this side. So r square plus z square to the power 3 by 2 is equal to 3z square r square plus z square to the power 1 by 2. Okay, so this cancels out with each other. There will be r square plus z square. So r square plus z square is actually how much? Is equal to 3z square, right? So I will take z square to that side. So z r square is equal to 2z square. We need the value of z, right? So z square is equal to what? R square by 2. So z is equal to what? R by root. Okay. So this will be our answer. So for r is z is equal to r by root 2, our electric field will be maximum. Is it okay? Is it all right? Is it clear to you? Is it clear to you? Hmm? Okay. Write another similar type of question. Consider 2 point charges. Consider 2 point charges Q and lambda Q located at the points x is equal to a and x is equal to mu a respectively. Okay, assuming that the sum of the two charges is constant. What is the value of lambda? What is the value of lambda for which the magnitude magnitude of the electrostatic force is maximum. Okay, option A is mu, option B is 1, Option C is 1 by mu. Option D is okay. We have time. Consider 2 point charges q and lambda q located at the points now x is equal to a, x is equal to mu a, respectively. Assuming that the sum of the two charges is constant, what's the value of lambda for which the magnitude of the electrostatic force is maximum? Consider 2 point charges lambda and lambda q and lambda q located at the points. First, draw the diagram for it. X is equal to a, x is equal to mu a. Assuming the sum of the two charges is constant, what is the value of lambda for which the magnitude of the electrostatic force is maximum? Okay, if you see what is the distance between these 2 points. One is that x is equal to a, another is that x is equal to mu a. So distance between them is mu a minus a, right? That's it. Charge is q lambda. What is the force then? Force is equal to 1 by 4 pi epsilon naught q into lambda q divided by mu a minus a whole square, right? And the force is maximum. What is the value of lambda? That means df by d lambda is equal to 0. We just did it in the previous question. Okay, so if you see d by d lambda of dy d lambda of this is a what 1 by 4 pi epsilon naught lambda q square divided by mu minus a whole square a square, isn't it? Right? Hmm. Now there is another thing here. If you see, um, mm, okay. Okay, see another thing. Here we have to substitute this q. Okay, because we see if you take the lambda here derivative, lambda will be gone. So we have to do something with it. Okay, see these are two charges, q and lambda q, and this is constant. The charges are not changing, right? Our charges changing. Oh, the charges are not changing. So what will I do? I let q plus lambda q is equal to constant. Okay, so q whole into 1 plus lambda is equal to constant. So q is equal to how much? C by 1 plus lambda. Constant by 1 plus lambda. So in place of q, I will put c by 1 plus lambda. So d by d lambda of 1 by 4 pi epsilon naught lambda. Okay, c square by 1 plus lambda square, and this whatever this thing is there 1 mu minus 1 whole square a square is equal to 0. So all the constant quantities will go and become 0. What will be left? D by d lambda. Only the things related to lambda will be left. 1 plus lambda whole square is equal to 0. Isn't it? Isn't it? So if you see the derivative of it is 1 plus lambda whole fourth and 1 plus lambda square minus lambda into 2 1 plus lambda is equal to 0. So 1 plus lambda whole square is 2 lambda minus lambda square. Sorry, minus 2 lambda square. So 1 plus lambda whole square is 2 lambda minus 2 lambda square is equal to 0. So 1 plus lambda square minus 2 lambda minus 2 lambda square is equal to 0. just this, and that will be 1 minus lambda square is equal to 0. So lambda square is equal to 1, so lambda is equal to plus or minus 1. Okay, that will be the answer. So, but minus is not there, so the answer will be 1. Okay, okay. Yeah. Next question. A spherical cell of inner and A and B respectively is made of a dielectric material with frozen polarization PR is equal to K by R cap. Okay, where K is a constant and R is the distance from its center. R is the distance from its center. Okay, the electric field in the region A less than or less than B is option A. E is equal to K by epsilon naught R cap. Option B is equal to minus K by epsilon naught R cap. Option C is equal to 0. Option D is equal to K by option R square. Okay. That will be the question. Let's try it. I want to a spherical cell of inner and outer radius I and B respectively is made of a dielectric material with frozen polarization PR is equal to K by R cap. The dielectric electric field in the region A less than B less than R. A less than R less than B. Okay, spherical cell of inner outer ready A and B respectively. B is made of a dielectric material with frozen polarization. This one. Okay. The electric field in the region A to R to B is okay. So see, uh, the polarization. Okay. See your what we have to calculate electric field in the region. So polarization. See, your this one rho B is equal to minus del dot P. Okay. And if you see del, I can write it as 1 by r square del by del r of r square. This is del square, sorry. R square, and your P will be your k by r, right? Right, k by r, sorry, k by r. Hmm. So if you do this is r and this is k, so d by dr of kr is k, so minus k by r square. Alright. Hmm. Now so your this sigma b is how much? Sigma b is your p vector dot n cap. Okay. So p vector dot n cap. The values will be p vector dot r cap is equal to k by b and r is equal to b. Okay. And p minus p dot r cap will be minus k by a at r is equal to a. Is it alright? Okay. For here we are asked for a less than r less than b. So here q enclosed is how much? Q enclosed will be this one minus k by a into 4 pi a square. Okay, because r is a. Okay, plus a to r minus k by r square 4 pi r square dr. This is for limit a to r. Okay, so if you see this is a cancelled out, so minus 4 pi k a. Okay, and this will be your minus 4 pi k goes out and r square is cancelled dr, so dr is r minus. Okay, because dr integration is r and to r that means r minus a. So if you see this will be your for minus 4 pi k a minus 4 pi k r plus 4 pi k a. So minus 4 pi k r. Okay, so electric field is equal to 1 by 4 pi epsilon naught q enclosed by r square. So electric field is equal to how much? 1 by 4 pi epsilon naught um, minus 4 pi k r by r square. Okay, and so 4 pi cancelled out. So minus k by r. Okay, this will be your. Is it okay? Oh, epsilon is there, sir. Epsilon. Okay, I hope you can understand this one. Okay. Write one homework. Write one homework. Number 8. Electrostatic potential. Electrostatic potential due to a charge distribution. Due to a charge distribution is given by Vr is equal to A e minus lambda r by r, where A and lambda are constants. Okay, the total charge enclosed, hmm, within a sphere of radius, 1 by lambda with its origin at with its origin at r is equal to 0 is given by A 3 pi epsilon naught A by E V 4 pi epsilon naught A by E C pi epsilon naught A by E D is 0. Okay. Initial potential due to charge distribution is given by Vr is equal to this much. The total charge enclosed within a sphere of radius 1 pi lambda with its origin at r is equal to 0 is given by this. Okay. So this is your question for homework. Okay. Please try this question and let me know in the comments how much you want. Okay. Okay. That will be it for this class. Okay. And thank you very much for joining. Thank you very much for watching. Okay. Thank you very much.